What are electromagnetic waves? See, what are the sources of electromagnetic waves and what are electromagnetic waves? See, the wave for which material medium is not required for their propagation are known as electromagnetic wave. Okay, the wave for which, for transfer of which, the wave for which no material medium is required, no material medium required, is for the propagation is known as electromagnetic waves. Okay, now what can be the example of electromagnetic wave? See, if I create a vacuum here in your place, if I create a vacuum and if I'm standing in front of you, if I create a vacuum, you will not be able to understand what I am speaking, but you will be able to see me. Why? Because for transferring of sound, material medium is required. But for transferration of for transferring lights, medium is not required. So the wave for which medium is not required are known as what? Electromagnetic waves. So what are electromagnetic waves? Lights are electromagnetic waves. Okay, now we'll see what's the theory in this part. The first point, electromagnetically generated wave cannot originate from either stationary charges or charges moving uniformly, such as steady currents, whereas the latter generates magnetic field that are time invariant. The former only generates electrostatic field. The radiation of electromagnetic wave by accelerating charges significant outcome of Maxwell theory, although this does not include the proof of fundamental result, but we can accept it based on the rudimentary qualitative reasoning. Imagine a charge oscillating at certain frequency. An oscillating charge is a type of charge that accelerate. This result in oscillating magnetic field, which in turn generate another oscillating electric field, and so on. This causes an oscillating electric field to occur in space. Consequently, as the wave moves throughout the space, the oscillating electric and magnetic field effectively regenerate one another. The frequency at which charge oscillate naturally corresponds to frequency of electromagnetic wave. The source energy, the acceleration. It might seem simple to test hypothesis that light is an electromagnetic wave based on the discussion that come before. One may assume that we would need to do is construct an AC circuit with current oscillating at visible light frequency, such as yellow light. Yellow light is a frequency of approximately 6 into 10 raised to 14 hertz. We can obtain even the most advanced electrical circuit, which is roughly 10 raised to 11 hertz. That is the reason that, as in Hertz's experiment, the experimental demonstration of electromagnetic wave had occurred in the lowest frequency zone or radio wave region. Hertz's effective experimental validation of Maxwell theory caused a stir and inspired further significant work in this area. Two significant accomplishments in this regard are worthy of recognition. Electromagnetic waves with wavelength between 25 and 5 mm. Guglielmo Marconi of Italy carried out Hertz research at about the same time and was able to send electromagnetic wave across large distance. Okay. In short, what are the sources of electromagnetic wave? What are the sources of electromagnetic wave? See, charges. If charges are oscillating, it will produce oscillating electric field. and rate of change of flux, it will induce an EMF. And also we know one more thing, that even EDL will be equal to d phi by dt. This was from chapter 6. This we studied in chapter 8. That means what? E will be equal to E into dl. If there is an electric field, there will be an electromotive force. There can be a question, how electromagnetic field can be produced? By charge moving, by charge moving at constant velocity, with constant velocity, or a stationary charge, or accelerating charge. Accelerating charge. So the right one will be accelerated charge. If velocity is constant, that means acceleration is zero. This will not produce electric field. Even this will not produce electric field. For production of electric field, charges must have acceleration. Okay, charges must have acceleration. And what will be the direction? We'll see the directions of electromagnetic waves. Let us consider this three axis. Okay, we have three axes. This will be y-axis, this will be x-axis, and this one will be z-axis. We have three axes. Okay, in x-axis, our charges, or there will be a displacement of wave. There will be displacement of wave. Okay, in y-axis, let us consider that in y-axis there will be electric field like this. Okay, and if it is in y-axis, if electric field is in y-axis, if electric field is in y-axis, see, like this. Then perpendicular to electric field, there will be magnetic field. It will be perpendicular. Electric field will be like this, magnetic field will be like this, and the velocity of particle will be like this. So when the charges will be flowing, there will be electric field, magnetic field, electric field, magnetic field, electric field, magnetic field, electric field, magnetic field. Okay. Yes. So what will be the direction? The direction will be, velocity will be perpendicular to magnetic field, and magnetic field will be perpendicular to electric field. This all three will be perpendicular to each other. Okay, they all three will be perpendicular to each other. Let's see some questions based on this. Which of the following wave does not require a medium for propagation? And the options are sound wave, electromagnetic waves, water waves, or seismic waves. I repeat the question. The questions are, which of the following waves does not require a material medium for propagation? Very good, Mamta. Option B. Very good. The right answer is option B, that is electromagnetic waves. Okay, but electromagnetic waves. The wave which does not require material medium for propagation is called electromagnetic waves. So right answer will be option B. Now, the next question. What is the speed of electromagnetic waves in vacuum? The options are 3 into 10 raised to 5 kilometer per second, 15 into 10 raised to 4 meter per second, 3 into 10 raised to 6 meter per second, or 3 30,000 meter per second. What will be the right answer? C. This is 10 raised to 6, Mamta. 3 into 10 raised to 6. Yes, A is the right answer. Why A? See, we have kilometer here. 1 kilometer is equal to 10 raised to 3. So already what we have, already we have 10 raised to 5. 1 kilometer will be equal to what? 1 kilometer will be equal to 10 raised to 3. So this will be equal to 3 into 10 raised to 8 meter per second. And Mamta gave the right answer, option A. Next is nature of electromagnetic wave. I already explained you this diagram. What is there in this diagram? In this diagram, what you have a direction of propagation of particle. Direction of propagation of particle. Okay, then what we have electric field and magnetic field. Electric field, and that is magnetic field. They both are perpendicular to each other. See, electric field will be like this, it will be like this, it will be like this, it will be like this, and our magnetic field will be like this. I'm using the same, that's why it will not be much difference, but you will understand. I have explained you previously also that how this electromagnetic waves will be there. Okay, we'll see the points related to it, then we'll see the 8 properties of for the natures. Yes, the first one is the electric and magnetic field of electromagnetic wave are perpendicular to each other, and also it is perpendicular to direction of transmission, and it was explained by Maxwell. Okay, so that point electric field is perpendicular to magnetic field is perpendicular to velocity. That was explained by Maxwell. Okay. Then second, the capacitor internal plates create electric field that is perpendicular to plate. Internal plate create electric field that is perpendicular to plate. This result in magnetic field that is parallel to capacitor plate and run the length of circle caused by the displacement current. Okay, what is there in the diagram will be given by in this point. What is the point? In this example, B and E are therefore perpendicular. This characteristic is universal. A common illustration of a planar electromagnetic wave moving along the z direction is shown in the figure. At a given moment, the electric field is along axis and fluctuate sinusoidally with once more varying sinusoidally with z, the magnetic field. Ex and By can be written as follows. I will give you few points how you can write these properties. Okay. So the first we'll see electromagnetic wave equation. First, what we have? We have y is equal to a sine omega t minus kx. Anything which is performing oscillation will follow this equation. Y is equal to a sine omega t minus kx. Here, even our electric field, it is performing oscillatory motion. So here what you will write? You will write E is equal to, amplitude will be E naught into sine of omega t minus kx. Okay, what is E naught? E naught is your, so what is E naught? E naught will be your magnitude of electric field, or it will be known as maximum value of electric field. Okay, maximum value of electric field. What is omega? Omega is equal to 2 pi f. What is f? What is frequency? Frequency is 1 upon t. What is frequency? Frequency is 1 upon t. And what is omega? Omega is known as angular frequency. Omega is known as angular frequency. Okay, then one more thing we have a factor k. That k is called propagation constant or wave vector, and that will be equal to 2 pi upon lambda. We will name it as propagation constant. You have already studied about this in your chapter superposition of waves. Propagation constant. Propagation constant. Okay, then this is for electric field. What about magnetic field? Magnetic field will be same. B is equal to B naught sine of omega t minus kx. I hope I don't have to write this again, that what is B naught, what is omega, what is k, what is x, what is B naught, maximum value of magnetic field, what is omega, angular frequency, what is t, time, what is k, propagation constant, what is the value of k, k will be equal to 2 pi upon lambda. Okay, this was your first point. Now we'll see the second one. What is second point? Second point will be E is equal to B into C. What is E? Yes, E is electric field. What is B? B is magnetic field. What is C? Yes, C is constant and it is known as speed of light. It is known as speed of light. Okay, it is known as speed of light. Third point, that electromagnetic wave nature are of transverse type. Are of transverse type. I hope you people know that there are two type of nature, transverse wave and longitudinal wave. The one in which vibration of particle is perpendicular to direction of propagation are known as transverse wave. And the one in which vibration of particle parallel to direction of particle, then it will be known as longitudinal wave. Okay. Then, so these were the 3 points we studied. Then we'll move further. Yes, I'll explain you once again what is there. Okay. So these were the 3 points. Now we'll see the fourth one. We'll complete the 8. Then we'll revise what other 8s are. Okay. Then the fourth one. Fourth one is our electromagnetic waves is in the form of energy. It will be in the form of energy. Then fifth momentum. If it is wave, there will be momentum. What is momentum? Momentum is mass into velocity. Okay, momentum is mass into velocity. We have E is equal to mc square. We have to find momentum. How we can find momentum? Momentum can be found as mc into c. What is mc? Mc is mv. Mv will be equal to p into c, and here we have E. So therefore you have p is equal to E upon c. Momentum will be equal to E upon c. What is momentum? Momentum is mc square. What is c square? C into c. What is mc? Momentum p. So here E will be equal to p into c. So p will be equal to E upon c. Okay. Then we have force. What is force? Force is momentum with respect to time. What is momentum? What is momentum? Momentum is E upon c into t. See, momentum is E upon c into t. Then what we have, seventh one, we have pressure. What is pressure? What is pressure? Pressure is force upon area. What is force? E upon CT. What is area? Area will be A. So this is pressure. E upon CT into A. Okay. Then one more thing we have. We have seventh. We have C speed of light. That formula of speed of light. That small is a formula. That 3 into 10 raised to 8. The value. It comes from here only. That formula is mu naught into epsilon naught. And that will be equal to what? When you substitute the value of mu naught, when you substitute the value of epsilon naught, what is mu naught? 4 pi into 10 raised to minus 7. What is epsilon naught? 8.3 into 10 raised to minus 31. So that will give you what? That will give you the value as 10 raised to 8 meter per second. Okay. So this C, where will be the C? The C will be in vacuum. And where will be V? V will be in medium. Where is medium? Whereas this will be in medium. This in medium, whatever the permittivity, whatever will be the permeability will be there, you can find the value of V. If you divide value of V and C, what you will get? Okay, if you divide the value of V and C, what you will get? By dividing the value of V and C, or C or V, you will get under root of C was 1 upon under root of mu naught E naught. V was is equal to 1 upon under root of only mu, only epsilon. So here that will be inversely proportional. So in place of C, In front of C, you will write mu epsilon. In front of V, you will write mu naught epsilon naught. So this will be equal to what? See, what is relative? What is C upon V? Speed of light in vacuum to speed of light in medium. That will be your refractive index. What is permittivity of material to permittivity of free space? It will be relative permeability. It will be relative permeability and relative permittivity. Okay, these were the seven. These were the 7 points. Okay, one more point. One more point. Yes, 8 to 1. 8 point. 8 point is where will be the direction? Yes, we already discussed about the direction. 8 point will be intensity. What will be intensity? Intensity means strength. What will be intensity? Intensity will be equal to P upon A. And what is P? P means pressure. What is pressure? Say, what is pressure? Intensity will be equal to P upon A. Sorry, here P is not pressure, it's momentum. So here it will be P upon A will be equal to E upon TH. And what is E? Energy. What is energy? What is energy? Energy is HF. Photon energy, HF. Photon energy will be HF. So here it will be NHF. If number of photons are more, then it will be NHF. And down we have TA. So this will be your intensity. Okay, once more. Yes. See what we have. I'll mark again. I will mark here what we have. The first thing. Ex and Bx. That means electric field and magnetic field. We have the standard equation. We can write electric field as E is equal to E naught sine omega t minus kx. And similarly, you can write for magnetic field. What is E? This will be Ex and this will be By. Okay. And then what we studied about omega. Okay, then we studied about the omega. What is omega? Omega will be equal to 2 pi f, or it will be equal to 2 pi over, it will be equal to 2 pi over t. Then we studied about k. What was k? Propagation constant, and that was equal to 2 pi upon lambda. That was equal to 2 pi upon lambda. After that we studied the second property, and the second property was E is equal to BC. What is E? Electric field. What is B? Magnetic field. What is C? What is C? C is speed of light. Then what we studied? Then we studied that our light is electromagnetic wave. Light is electromagnetic wave. Okay, light is electromagnetic wave. Which type of electromagnetic wave it is? It is of transverse type. Fourth, we studied that light is in the form of what? It is in the form of energy. Okay, fifth, we studied that about the momentum. What is momentum? Momentum will be equal to E is equal to mc square. So this will be mc into c. So this will be equal to mass into velocity will be momentum into c. So your E is equal to pc, therefore P is equal to E upon c. Okay, then we studied about force. What is force? Force is pressure per unit pressure. Force is change in momentum with respect to time. Change in momentum with respect to time. What is change in momentum? E upon c into t. Then we studied about the pressure. What is pressure? Pressure is force upon area. Force upon area. What is force? Force is E upon ct into a. Then then we have c. What is c? 1 upon mu under root of mu naught epsilon naught, or v is equal to 1 upon under root of mu epsilon. What about the ninth one? What about the ninth one? Ninth is if you want you can divide and you can get the value in terms of permittivity. Then ninth one was intensity. What was intensity? Intensity was p upon a. What is p? P was E upon c into a. Sorry, p was E upon c into a. Okay, what is E? NHF upon ca. So these were the 8 to 9 points. 2, 3, 4, 5, 6, 7, 8, 9. This were the 9 points we'll have to remember for the properties. Let's see some question based on this. And the questions are, and the questions are, what is the relation between frequency and wavelength? And the options are inversely proportional, directly proportional, no relationship, or random relationship. What is the relationship between frequency and wavelength? Inversely proportional, directly proportional, no relation, or random relation. Frequency and wavelength are inversely proportional. Frequency and wavelength are inversely proportional. So option number A. After removing this property sign, there comes the hero C. What is C? Say, what is C? Speed of light. C is speed of light. What type of wave is electromagnetic wave? Transverse, longitudinal, sine wave, or none of the above? Transverse, longitudinal, sine wave, or none of the above? Which type of wave? Which type of wave? Yes, we have already discussed about it, the nature. What is the nature? What is the nature? What is the nature? What type of wave it is? It is transverse wave. It is transverse wave. Okay, then I also explained you what the difference between transverse wave and longitudinal wave. Now, March 2023, 1 marks a question on your screen. The question is The A and B represent electric and magnetic field of an electromagnetic wave respectively. The direction of propagation of wave is along vector B, vector E cross B, or vector BE. Please let me know. E and B represent electric and magnetic field of electromagnetic wave. The direction of propagation of wave is along what? It will be represented by vector. Which vector? It will be represented by vector E cross C will be the right option. Option C will be the right option. Okay.